It's working. Thank God. This is not easy. I feel like this was working before and then it stopped working and then I don't know what to say. All right, so welcome to another exciting biomedical imaging class. I handed out the syllabi. If you didn't get one, you should have one. Whoa, I can see why you don't want wires there. And one of the things I can tell you about the syllabus is it tells you a little bit about some of the topics that we'll cover in class today, but also it gives you some idea about the prerequisites. Usually you want to have a course in signal processing with a little programming in Java in your background. And if you don't know any Java, you could feel a little pain in this course. So I'm going to be using Java in my examples. I'll be giving you regular programming assignments, and then you can do those assignments in any language you like. I don't care if you do them in MATLAB. I don't care if you do them in C. I don't care what language you pick, but I'm going to use the language I like, and I'll use Java. And I'll be teaching the book using my image processing in Java book. And I brought a few copies here with me today. And I can sell them to you now. They're brand new with unopened CDs. And they're yours for the low, low price of $30. The book is probably available inexpensively used. Sometimes they come with busted CDs. Sometimes they come a little beat up. These are brand new. One of the things I'd like you to do is sort of make sure that you know enough Java to feel comfortable in the course. And one of the things I'm going to do is I'm going to start the class a little bit by introducing you to the basic concepts of how to build the code. So I'll be sending out an email to the class list so that everybody will know how to download the code. And then what I'd like you to do is take an opportunity to try and do the build. So when you do the build on this, you'll probably want to install some sort of an IDE, an integrated development environment. The one which I use is IntelliJ, but you can use whatever you like. Some people like NetBeans, some people like Eclipse, some people like IntelliJ. If you like to use IntelliJ, I distribute the key so that everyone can install it for free. And that way you can install it on your computer. You'll need a reasonably good machine to do this. The machine I have is probably getting long in the tooth at this point, but it's considered an elite book, whatever that is. If I go to the control panels and look up under System, I think we can get an idea as to what kind of machine we have. Here it says, I guess that's a dual-core i7. Does anybody know? I don't even know anymore. I think that's the i7 is a dual-core. 4 gigs is probably a good minimum. You don't really want to try and do a build with less than that. I got a 64-bit version of this operating system. I'm not even sure if it can. If you have 32 bits, I don't even know if you can go to 4 gigs. Probably only recognizes 3 gigs or something like that, right? So you probably want to think about using a reasonably modern computer. I suppose this is considered reasonably modern. Some people will use Windows 8. Does anybody here use Windows 8? Yeah, you like it? No. Okay. Does anybody actually like Windows 8? No. It does? Oh. Used to, yeah. That's what the real estate agent told me about the train that goes by my house at 4 in the morning. She said, you'll get used to it. That was in 2003. And I'm still waiting for, that time when I get used to it. At this point, I just close the windows in the summer, and then I'm used to it. The thing that's really difficult is getting used to the musical gravel cars at midnight because they move the gravel cars. They're all full of gravel. It's very loud. There's some basic ideas about signal processing, which I'm going to kind of assume that you all sort of know. Okay. Now let me see if I can get in touch with your memory about these ideas. Okay. And you all can shout out, very informal here. What's convolution? Yeah, that's a thing with signals. Yeah, good, good. Absolutely, it involves signals. That's very good. Can we pin it down a little more? Yes, yeah. Yeah, that's right. You flip around, then you do multiply and integrate. So this is good. We're having a nice sort of interaction here. Suppose I wanted to do the convolution digitally. So now let's assume that my signal consists of a sequence of numbers. And now I've got another sequence of numbers. Right? So let's call the first sequence X. And the second sequence we can call Y. Okay? So if I take X and I number it, it's X1, X2, X3, X4. If I take Y and I number it, it's Y1, Y2, Y3, Y4. Now let's assume I'm going to take these two signals, which are consisting only of 4 numbers going in sequence, and I want to perform a convolution. Well, what do I do? It's a thought process. Yes, sir? Use a Fourier transform. Ah, you're killing me. Yes, yes, because if you put it into the frequency domain, you can do what to affect your convolution? Suppose I take a Fourier transform of X and I take a Fourier transform of Y. I wasn't going to mention that, but you brought it up. So now what? Multiply them. Yeah, when you multiply, it's a convolution in the time domain. So multiplication in the frequency domain is really convolution in the time domain. That's a basic theorem, and that theorem has a name. And what do you suppose they call that theorem? The theorem of convolution. You could call it the convolution theorem, so you're very close. That is the convolution theorem. And that's one of the basic things I would expect people to remember from a signal processing course. Really basic idea. That is to say, multiplication in the frequency domain is equal to convolution in the time domain. So that's good. But suppose that with only 4 numbers, a Fourier transform is an over-the-top computation that actually takes longer than a direct convolution, where direct convolution means you just do the convolution operation without going into the frequency domain. So, and that's true, actually. When you only have 4 numbers, you really don't want to do a Fourier transform. It's not appropriate. It's just going to slow you down. So, instead, what you want to do is a direct convolution operation. 4 numbers. So what do you do with those 4 numbers? You can just tell me in words. I'm not going to ask you to write the code for it. Well, you said it, right? You said flip it around. Oh, yeah. Right? So you take Y1, Y2, Y3, Y4, and you transmogrify it into somehow through, programming or whatever. You turn it into Y4, Y3, Y2, Y1. So you invert it, right? That's what you said. Right. And then what do you do? So then, you have to integrate them too. So I guess the way that you have to overlap somehow. Yeah. So you make what's called a slider. You take the numbers and you overlap them by 1. You multiply them and add. Then you move them overlapping by 2, multiply and add. Then you move them again, sliding, multiply and add. Then you move them again, multiply and add. then you move them again, multiply and add, move them again, multiply and add, move them again, multiply and add. Each time you get a number, when you do the multiply and add, we call it a sliding dot product. A sliding window dot product, because when you take two numbers and multiply them together, two vectors, multiply them together and then add the results of the multiplication, that's a dot product. So what you're doing when you're doing the slide is you're shifting by one the index of the y vector against the x vector, and that's called a direct convolution. And guess what? If you did do the Fourier transform, you'd have to pay a space penalty. What would the space, the memory penalty, be if you did a Fourier transform on the computer? One of the things that characterizes Fourier transforms, if you take the Fourier transforms of 4 numbers, how many numbers do you really end up with? The answer is 4 numbers, but those numbers are interesting, right? You started with real numbers, but you're going to end up with imaginary numbers, right? They'll be complex numbers. So when you take a Fourier transform and you go into the frequency domain, you get complex numbers. Remember, mathematics isn't about finding x. Mathematics is also answering the question about why. Why will you get complex numbers? Why do you need complex numbers when you do a Fourier transform? What do you need that for? Go. You look like you're about to... Yeah, every time I try to get a simple answer to a question, you just introduce this whole big abstract other thing. Yeah, you could use Hartley transforms, but let's forget about the Hartley transforms for now, and just try and go to the basic answer of the question. When you take a Fourier transform, how come the output is complex numbers? You got a real part and an imaginary part. Why? Frequency is only one component of a partial, right? So what the other component is phase. You need frequency and phase. So how do you represent the frequency and phase? Well, you take the amplitude of the cosine part and the amplitude of the sine part. And you figure that those two things are orthogonal with respect to one another because they're 90 degrees out of phase. And if you want to represent them with a single complex number, and the real part is in the cosine and the imaginary part is in the sine, you use a complex exponential using a relation. What relation is that? Euler. Yes, because r(e) to the I theta is equal to r times the cosine theta plus I times sine theta. Right? So what that does is it says, aha, I have a triangle where the base of the triangle is the cosine, r cosine theta. That amplitude is the x component, or the real part, and the I'll call it imaginary magnitude is represented by r times I times sine of theta. That's the imaginary part. So now what I have is the ascendant part of the triangle, ri sine theta, and the base of the triangle, which is r cosine theta, and the vector is the hypotenuse that connects the two. That's the complex number. And that is essentially all REI theta is representing, where theta is the angle of that vector, and r is its magnitude. And so only thing you get to do when you are representing complex numbers is you represent a series of vectors in the complex number plane. And that's why when you take a Fourier transform, you need complex numbers to represent the underlying real valued signal. And that's why you don't do a Fourier transform when you only have 4 numbers in a vector. Right? That makes sense, because all you've done is you've taken 2 simple 4 element sliding dot products and turn them into like 8 numbers, and then you have to do the multiplication, then you have to do the inverse Fourier transform, and you're basically throwing out all this internal memory when you go back to the real valued signal. So it helps you only when you get to what I call the break-even point. And that is different for every computer. Because when you do a sliding window dot product, you've got triply nested for loops, right? You not only have you flipped around the y, but you have to go through with a for loop and do your dot product, then you have to do a slide and do a dot product and another slide and a dot product and another slide and a dot product. Every dot product has got to have for loops. Every slide is going to have for loops. It's one of those things that has what I will call a quadratic execution time in n, where n is an integer, right? The number of elements in the two vectors that you're trying to multiply. And that will essentially tyrannize the computation after a very short while. That is, after perhaps 256 or 512 elements, it's going to get so cumbersome for the computer, you'll go back and start thinking about Fourier transforms. But until then, you won't bother. How am I doing here? I'm just trying to review the signal processing concepts, and I might be going fast, but I just sort of thought, you know, these are the things that you guys probably know, right? Sort of. I'm all right? I'm not going to whip out my PowerPoint slides and do the PowerPoint death march here, although I could. And I'd love to do a little board work. But as you can see, the board is not ready for prime time, and they really don't want me to write on the wall. Although I figure, what the heck, it's big science. So I thought it would be fun to try a learning activity. So here's my learning activity. What I'm going to do is I'm going to fire up my little computer here, and I'd like to bring in like the command prompt, CMD. Okay. I don't know if you guys are used to using the command prompt. Somebody made a comment earlier today that they don't feel comfortable with it or they don't use it very much. I have some facility with it, so I use it all the time. But there are certain things about the command prompt that I happen to like that allow me to sort of dig into the operating system. And you can do this on a Mac, and you can do it on Windows, and it kind of is, I'll call it an operating system agnostic element. Okay? So here's a thing that I like to do. What's this window here? This says CMD-EXE. What is that? You guys know what that is? You see where I'm typing? And I type in dir, and it lists the files, and cd ... Well, what is this cd ... What's that do? Change directory. Good. And what does the ... mean? Goes above. Okay, that's great. And then what happens if I want to complete a name without typing the whole name? Tab, sure. And then that does it for me. And so the question is, right, not X, find X, it's also answer Y. Why does this work? How is it able to find the command, let's say, msconfig? How does it know where that is? What is this thing, this program I'm running, this command line interpreter? How does it work? And why does it find all of these interesting and wonderful commands? It's actually a program. The command prompt is a program, and it's called a command line interpreter. And what it does is it reads your text, and then it evaluates it. It takes the first token that you type, and it searches what's called the path. When you are in DOS and you type the word path, it outputs a series of directories. The directories are semicolon delimited, and they essentially give you the location for all of the executables that can be invoked. So, for example, when you look through this path, you should be able to find Program Files right in here, and I'll mouse right, hit Mark, click to the left and drag to the right, and check it out. It says Program Files Java JDK 1.6, the old version of Java. It's in my path. It might not be in your path, but if it is in your path, it'll find that bin directory, and in that bin directory will be a whole bunch of JDK commands. If you want to find out which version of Java you're running, type Java -version. Okay. That'll generally work if Java has been installed. But check it out. My path is showing JDK 1.6, but when I type Java -version, it says JDK 1.7. That must mean I have two different JDKs. It probably means that my path variable is essentially wrong, and now I have to go fix it. Fixing your path variable so it's consistent with the JDK and the commands that you're running is absolutely essential. So this is a good life lesson right here. My path is wrong. How do I fix it? What do I do? Well, first thing I say is, which JDK do you want? You want the JDK 1.6 or you want the JDK 1.7? And if the answer is you want 1.7, because it's the latest one, then what you want to do is you want to go up to the Program Files, and you want to go into the Java directory and type dir, and sure enough, there's two different JDKs installed. One of the JDKs, JDK 1.6, is in my path. The other one has its Java virtual machine, also in the path, but none of the tools are in the path. So I got to fix this, right? I've got two different JDKs, but I've got a confused install. That's classic, because I just installed one thing on top of another without doing it properly. And properly means having consistent JDK tools in your path. So if you want to do that, first thing you want to do is grab the correct path, JDK 1.7, if that's the one you want. We'll call that the correct path. And then we'll go into the bin directory, and we'll look for exe files, and sure enough, there's a whole bunch of executables there. Those are the ones I want in my path. I want to have the correct JDK in my path. So, mouse right on this and do a mark. I'll say one thing about the copy and paste action of DOS. It's quaint. It's very quaint. And nobody does it like this anymore, but because DOS dates back to, like, I don't know, the early 80s, Windows, before Windows, right? They had DOS. So hit Enter, and that takes the highlighted text and puts it into your clipboard. Now go into the, I'll call it Control Panel. Go into your System. Go into where it says Advanced System Settings. Go down to where it says Environment Variables. Click on the text field in the lower part, which is called System Variables, and look for that path, and there it is. That's your path variable. Edit your path variable up, and what you should be able to find in here is the old version of the JDK. And so you may have to scroll around a bit to find it. As a matter of fact, I'm having a little issue trying to find it. I know it's in there because when I go in here and type in path, it's after Emacs, after Tomcat, but it's toward the end. It's like this part right in here. Oh, I don't want to do that. I already got something in there. So let's go back. I think it's after, wasn't it after the Emacs? Maybe not. I'll use my arrow key. Somewhere in here there's going to be like a JDK. If this doesn't come up soon, I'll use Notepad to do my editing, which is kind of okay, I suppose. Select all, copy. Let's go into Notepad. paste, and there it is. So somewhere in here, I should be seeing Java. Does anybody see it? It's not here. Really? So when I typed path, it was there, but I'm not seeing it. Isn't that interesting? I don't know why I don't see it here. It should have been there. So let's go and get the path variable here. Hit enter, and now paste it into the notepad area. Semicolon is your path delimiter. Hit paste, and there you have it. That's what you want for your path. And what I would do is just make sure you've gotten rid of all of those carriage returns. Then do a copy and paste. And there's the JDK. Hit OK. And let's just make sure it's in there. Yep, there it is. So hit OK. Hit OK. I guess we can close this out now. Don't save. And now if you hit exit and restart your command prompt, it's in there, but I also see another one in there. Isn't that funny? Yeah. Maybe that's what's doing it, huh? Well, at this point now, it looks like the JDK 17 is overlaid on top of the 16. So when you type jar, I don't know if you can get a version out of jar. There should be a way to get the version. I, at this point, would say let's uninstall the JDK and reinstall it. I might even uninstall both, just because I can't stand the idea that I would have uncertainty. The other way to go is you could create your own custom batch file, which I've often done, and that'll set up your path just the way you want it when you log in. And that's a good way to go, actually. So what happened here was kind of a flub, because I'm looking here and I see all this stuff that didn't really appear in my path before. Mark, copy. Whoops, that was bad. Mark, copy. I think I got everything. Enter. Notepad. Oh, really? Paste. I mean, it's got all this stuff in here about Apache, which I don't want necessarily. It's got stuff in here about JDK 16, which I don't need. I got Apache Ant, which I don't need. I could really customize this and make it nice. But you can see I didn't do a clean paste. So putting all of that into the path variable is probably not a good idea. And what's this WBEM? Isn't that a virus? Oh, I think I'm infected. WBEM is a virus, isn't it? That's like a worm. Oh man. Gee. Oh, I have an infected computer. I'll have to go fix that. I didn't anticipate having an infection during class. It's so embarrassing. I feel violated. So anyways, after you get your JDK set, you should be able to do a download. And what I'll do is I'll send you guys a link to my Dropbox so you can all get the code. And you'll need two things. You'll need the SRC, and that's the source code. It's all in a big jar file called src.jar. And you're also going to need a because I rebooted, I have to reconnect to the net. Yeah, I have to reauthorize when I reboot. There you go. Now I can get to the Dropbox. So what you'll do with the Dropbox is you'll find two files. There's the jars.jar and there's the src.jar. And once it's downloaded, you'll want to unjar it using the tools that are available in the JDK. I like to use the jar command. So I say jar -xvf src.jar, and that gives you the entire access to all of my source code. So here's the command prompt again. I go into my downloads, and the jar file src.jar can be extracted with jar -xvf src.jar, and that gives you all the source code. Similarly, with the jars, you'll want to get all of the jars and all of the source. The jars contain all the libraries. The code will not build without all of the libraries. Once you have those things in one folder, you can do a proper build of the code for the course. Yes, sir. And it's very similar to last semester. I've been working on it during the break, so you might want to freshen it up. So what I did was I did the download and the build already, and I put it into a J4P folder in my Lion directory. And it takes a while to do the build, several minutes, really. And then when you're done, you'll have your jars, your source, and your data. You won't have your out file. You won't have your IntelliJ IDE folder. That's for the IDE. And you won't have the J4P folder. Then you're going to do your build. You'll start IntelliJ. And there's a new version of IntelliJ out. JDK 1.7 runs fine with it, but I think they're out to IntelliJ 13. And I've been playing with IntelliJ 13 during the Christmas break. And it seems to work reasonably well, but it's got a couple of foibles that I'm not too fond of. So I'm not going to discourage you from using the latest version of the JDK and the latest version of IntelliJ, but I'm not entirely sure that I feel really comfortable with it, because it does things to my code that I cannot seem to control. Well, it'll take the carriage return that comes after an open curly brace and erase it and put the whole statement on one line. So it materially changes the formatting of my code, and I have not been able to control that activity. And when it occurs, I fight the IDE by putting the carriage return in, and then it fights back by taking it out. And then I complain to tech support that this is not correct behavior, and I want it to do what I want, and I don't want it to sit there and start taking multi-line code and turn it into single-line code, because I don't care for that style. It's not my style. It's their style, and I want my style. And they just said, well, you're not using it right, or you're doing something wrong. And I'm sitting there going, yeah, okay, help me. I have to get used to it. I'm still running. I'm running IntelliJ 13 at home, but on this computer right now, I still don't feel comfortable enough to do it in class. And I'm not sure exactly what the story is with that. It's just me being slow to learn, I guess. Put it that way. So here's what I've been working on. It's all very fun. It's an address book. Mouse right on main and hit run. And the address book program is not particularly remarkable, except that here it is with my 5,161 closest friends. And you can use it to do various interesting and wonderful things. Like, for example, if you encounter a voicemail system that pisses you off, it can navigate through it automatically. That's cool. Because what that means to me, the user, is that if I have to hit 1 to get English and then hit something else to get something else, this can do it for me. So for example, let's say I want to go in and get my messages. Well, I'll just make up a here, 'cause there's too much sensitive stuff here. So let's say you want to get your messages, right? So to get your messages, you dial 203-555-1212, your cell phone number. Then you want to put in a pause. So a couple or 3 pauses, and then you want to say hit star, and then you want to enter in your PIN 1234, and then you hit something like pound to terminate the PIN, and then all you'll need to do when you hit done is go to dial, and it'll just dial right through and get your messages. And so what that means is you'll kind of be able to be a little less distracted by the prompts, and it becomes quite cumbersome if you're trying to get through certain kinds of voice jail. So if you know the voice menu, you can hack, right, the voice jail system and customize your dialing procedures. That's kind of cool. No, this is Java. So cell phones use something else, right? Like iOS won't even. I think Apple has practically outlawed Java on the cell phone. Yeah, there's a hack. I did a hack on my iPad, and now I can run Java on my iPad. But if I tell the tech geniuses over in the Genius Bar about it, they ban me from the store. They won't let me in anymore. They get all pissed off at me when I ask them questions about it. Yeah, it violates the warranty when you install the hack. They call it Cydia, and it's insidious because of the warranty. But I like my iPad with Java, but I can't encourage you to do that. I jailbroke it, yes, and now it runs Unix, and I have Unix commands in my iPad, and it runs a full-blown development environment, including Emacs and Unix and everything. Well, I mean, it's in a case. I've dropped it. It works reasonably well. So the other cool feature, which I just added to this, is that it no longer uses Java native interface, JNI. Instead, it uses Java native architecture. So when I go to do serial port setup, in theory, and I'm having a little issue with it right now, you can see it's really having a problem. Wow, he's stuck in a loop. I didn't have this problem on my Mac. I better do some debugging. Yee, this is bad. Ooh. Yep, not ready for prime time. It's so new. I have to do debugging on Windows now. Java Network Architecture is supposed to load dynamically links to all of the operating system resources you need in order to get to a serial port, where the serial port is used to drive a modem, and the modem is then used to do your dialing. So if you want to do dialing with touch-tone modems at high speed, you really need an external connection to the phone line. And it has to go through either the modem built into the Mac, or it has to go through an external modem on the serial port. So in my case, what I wanted to do was be able to show you some of the features that this, I'll say, new address book program has. One of them was the ability to interface to the Dymo labeler, which I thought was kind of cool. But the other thing it has, and this is sort of an interesting thing, it has network capabilities most address books don't have. Like, for example, it can do data mining, and it can populate its addresses by going out to the web and doing what's called screen scraping. Now, the screen scraping process means that you can go out to the web, you can find data, and you can take that data and internalize it into your own program. That is, you can create a mashup and use the data for your own uses. So, for example, here's a, and this is kind of related to the networking course. So here's the thing called TomTom data mining. Now, what this does is, if I want to find a gun, and I'm in Virginia, and you know they have these gun shows there, no questions asked. You can go and you can get these things. They have like a 71 millimeter diameter, and they're collectible because they're used in the Vietnam War. They call them M79 grenade launchers. So let's say I need one bad, right? They don't have to shoot grenades. You know, they can shoot flares, which is, you know, okay. They can also shoot gas and smoke. So let's say you're in a hurry and you need your gun in Virginia. So you say, I'm in the city of Arlington, I'm looking for a gun. So then you want to download it in TomTom format, which is the OV1 format, or you might have a Garmin or something else. And so this will give it to you, and then you can take that file. And I don't know if you know this, but TomToms are actually running a Debian Unix. So when you go into their file system, you can take the files and you can do copies right across the USB port. And so they mount as file systems, and within your computer you can gain access to their full file system, take files and put them into the TomTom, and then you have what they call points of interest. So when you're in a TomTom and you're looking for points of interest, like, you know, the local gun store, or maybe you do something less, you know, here, let's make it antiques. Here, it doesn't have to be guns. Or maybe dentists. Maybe you need, or maybe you, after this you're going to need a lawyer. Right. So let's look for a lawyer. So maybe you're in Connecticut and you're looking for a lawyer. That's good. And you're within 25 miles of the city of Fairfield. So let's find all the lawyers within 10 miles of Fairfield in Connecticut, and we'll export it as a text file. That's good, because then we can read it. So now we'll just say OK. And then what this does is it goes out and it says something is wrong. Oh, really? This could be because I'm behind a firewall. Here's the base URL, and he wasn't able to make a connection. Copy. Let's just make sure that connection still works. Paste and go. Oh. The Yahoo API changed. Wow, okay. Do I have to... when the URLs change, then I have to change my code. Oh, I should have checked this. Or maybe it's because I'm... Actually, the Yahoo API might have changed. After Marissa Meyer took over, a lot of things sort of changed. Well, once you get the API correct for this, it'll start to work again. So I got what we call the data mining address book. I'll have to go home and make sure it's not because I'm here. You know that there may be a firewall or a proxy server involved, because whenever I try and connect to the network, I have to go through another barrier, right? It doesn't just let you on the network, you have to log in. So there is a proxy server when you come in, and it doesn't just let you get on the network. So we have to know what the proxy server is, and then we have to set it up. That's part of network programming. Absolutely. So I can show you that too, but it's another feature, right? So getting past the network and doing our network programming is going to be part of the hack that we'll learn in this course. I didn't realize that. You know, when you're it's such a key element. If you're running Internet Explorer, let's see if it's in here. Do I have Internet Explorer? I do. I don't know if it works. Does Internet Explorer work? There should be something like preferences, right? Options. And then maybe it's an advanced option, but it should show you the proxy settings. Maybe it's under connections. LAN settings, could that be it? See, this is not telling me what the name of the proxy server is. But one thing you can do when you're in the command prompt is you can say ifconfig or ipconfig. It's ifconfig when you're on the Mac and ipconfig when you're on Windows. And it'll tell you a little bit about the network connection that you've got. And this one tells me my IP address, which is a non-routable address, and we'll talk a little bit about that. And it also gives us some information about my IP address and the IP address of my gateway. No, I gotta know exactly what's going on here, because normally I could ping something like Google. Yeah, it's fine. So that may just be, it may be Yahoo changing its API. That's kind of interesting. So then let me get into this other thing that I guess is a somewhat more relevant area, and that's the imaging. So here's some of the imaging code, and what we'll do is we'll run IP.main, that's image processing, and here is type G for get GIF. Let's see if we can find a GIF image to show. Images, color, and here's an airplane. Good. So now we got an airplane. So there's a little image processing program. If you type escape N, it negates the image. It's image processing. See? Image processing. How fun. If you want to, you can get these edge detectors. Here's a little Roberts edge detector. And if you say escape U, it does a uniform non-adaptive histogram equalization. If you do escape N on top of that, changes it a little bit. If you want to, you can get some effects. Here's a 3D image which takes the height field and maps it into a 3D polygon array, so that you know, that's kind of like image processing, sort of. And then you know, one might ask a basic question like, what is image processing? And that's a good question, actually. So let's turn it back a little bit. What is signal processing? Like in voice and signal processing, we had a course, biomedical signal processing. What is signal processing? Say it again?
Just take it in a signal and do something with it.
Take in a signal, do something with it, and then maybe output a signal, right? So what we have is one-dimensional signals going in and one-dimensional signals going out. So it's a kind of one-dimensional data processing, right? Where the signal is just an array. The digital signal processing in general involves an array. In image processing, we have a kind of signal processing, only instead of a one-dimensional array, two-dimensional array. And that's it. So the difference between voice and signal processing and image processing is the difference between one-dimensional arrays and two-dimensional arrays. And that's it. End of class, you're done. You just learned it. That's it. No, there's more. So all the rest is techniques, right? We're all using the same computers. Convolution theorem still applies, only now when you do the convolution, you don't do it in a one-dimensional vector. You're doing it with a two-dimensional array. And then when you do your Fourier transform, you don't do it with a one-dimensional vector. You do it with a two-dimensional array. So that is a big difference, right, in terms of computation. And if you have an image sequence, people who are not in the field will not call it image sequence processing. They will call it video processing. So if you have an image sequence of images, and you process them sequentially and then output them sequentially, you're doing image sequence processing. That's true, but others will say you're doing video processing. So that's an interesting point. So then, if you look at it that way, when you do biomedical imaging, you're doing a kind of image processing with a biomedical application. And so now what you're thinking in terms of doing is, with biomedical imaging, is you're changing the sensor. But you're not necessarily changing the image processing algorithms that operate on the sensor. So if you think in terms of the sensor for the image processing that we're used to, the common one, maybe it's just a simple camera. But if you take that camera and you point it at, I don't know, the oculus of a microscope so that it can see a cell, then that becomes biomedical imaging. If you take the camera and you make it a new camera that sees X-rays, right, it's still biomedical imaging, right? When you look at Hologic and their camera, they make these huge CMOS X-ray cameras that are very sensitive, meant for 3D digital mammography. So when we think in terms of the kinds of sensors that we use, biomedical sensors, they kind of drive the biomedical imaging, but at the core of it is image processing. So changing the sensor, that's kind of nice, but at the end of the day, we still need to do things, basic things, like convolution and edge detection and low-pass filtering and high-pass filtering, and doing the kinds of things like building a 3D model of the thing we're trying to image. Those are the kinds of things that you would expect to be able to do in a biomedical imaging class. I'm thinking that we should do breaks. So this is a course that goes from like 2 to like 5. I'm sorry. Does it say 5 to 7? But that's only 2 hours. 5 to 7:30, right? 5 to 7:30. So right now we've been at it for about an hour and 15 minutes. That's about midpoint. So what I'd like to do is stop, take a break. There are snacks in the main School of Engineering office, which distance learning students don't get. And if you want to, you can join me for a snack. They're really very good. And they're Middle Eastern snacks. If you're unhappy with the amount of butter in them, you can always substitute heavy cream. So let's stop this for a moment.